messages what you have got that you want this much price. If you really want to avail that price, you have to pay the initial money of 5,000, 10,000. So all these messages are mostly, I mean, 99% these messages are a spam. Okay, and that we have to analyze by ourselves, and we are getting many messages throughout the day. Or sometimes if you are really very busy, then you feel irritated every time when you receive these kind of message in your mobile. So the job is now, so develop a classifier such that it can automatically label every message in your mobile phone, whether that message is a spam message or ham message. So that's what the overall the problem statement. Okay, for that one, this is the data set. Now we'll directly dive into the hands-on. So see, so something suppose you have in the drive, then how to read. And yesterday or day before yesterday, one madam was asking that how to keep a particular file or folder in a particular drive, in my drive and in a particular location. For example, suppose I have developed this code.
Excuse me, sir.
Yeah.
Sir, can we get the data set?
I'll send you the data set right now. It will take time, right? And we have hardly 1 hour. So I'll send you later on. Okay. Tomorrow. Maybe later on when I'm sending you all this stuff. Okay. Yeah. Okay. Well, so where I was, yeah. So suppose you want to create a new collab file, and you want that file to store it in a particular location in your drive. Fine. So the one way is you go to a particular location in your drive. For example, I am in my drive. Inside my drive, I am in workshop/FDP sessions, and inside this folder, I have another folder called as ATAL FDP HandsOn. Right now, I am in this folder. Okay, and now suppose I want to create one new file, collab file, and I want the location of that file should be in this folder. So what I'll do is I'll come to this folder first of all, then I'll go to this new. Okay, and then I'll go to more and I'll create the collab. Means I will open the new collab notebook. So as soon I have clicked that one, a new tab has opened. I'll show you. A new tab has opened, and I'll show you that one, but I'm giving the name of that tab, that FDP day 3 classific day 3 hands-on. It's hands-on, right? And now if you see there if you can see in the screen, that new file which I have created, that has appeared here, right? So if you will go like that, your file will be saved in a folder where you want to be. So I have created just now FDP day 3 hands-on. That is the file which I have created. Okay, so here it is. So this is how you can save your file in a particular folder inside your drive. Fine. Now I'm going to that file which I have created. So I have to stop sharing this tab, and I will go to that tab, because this was the question which I got, so I was just explaining. Yeah. Now see, this is the tab, or this is the file which I have created. So as usual, as I said you that day also, first we'll connect. Sorry. First we'll click on this connect button so that I can get a space from the cloud. Some resources from the cloud will be allocated to me. Then I'll go to this folder option, and I will click on this one. Drive. Why? Because my data is inside the drive. Okay, my data is in drive. I am right now in collab. So I want to mount my drive such that I can use my data. So I'm connecting my Google Drive, and see, now drive option will appear here. It is not now till now, but it will appear here. Yes, now it has appeared. Okay, so inside the drive, I will go to the my drive. Okay, and inside the my drive, I'm going to this folder, workshop FDP sessions. Inside workshop FDP session, I am going to this ATAL FDP hands-on, and inside that one, I have this data SMS spam collection. So suppose I want to read this file. So what I'll do is I'm just going to copy the path of this file. That's all. Okay. Now to read this file, what I will do is I will use the pandas. Import pandas as PD. I showed you that day that we are going to use the pandas in some way. So first we have to import the pandas library. PD is the object for that one. And then through this object, I'm going to call a function read underscore CSV. Read underscore CSV, and then inside that one, I am going to get the path which I have just copied. So this is the path which I had copied. Okay, so I can remove this part content. So inside my drive, then I'm going to the my drive, and then I'm going to the workshop FDP session, then ATAL FDP hands-on, then SMS collection, and then CSV, right? And then along with this, what I'm doing is I'm keeping some more parameters here. I'll tell you why. So one parameter is called SEP, which is known as the separator. What is the separator here? The separator is tab. That's why I have kept the character /t. I'll tell you what is the meaning of that one. And one more parameter what I'm keeping is names. And inside the name, I am keeping two different names, one for label and one for message. Okay. For the time being, what I'll do is I'll just comment this line. I'll show you if I'll not read the things like that, then what will happen? I mean, what I mean to say is if I'll copy only this part, I'm closing this, I'm running this, right? Okay. Suppose I have run this line. So what will happen? So there is an error, pd.read underscore CSV. What is that error? Error tokenizing the expected two fields in line 12 saw 4. What is this? Okay. There should not be the problem. Still same, import pandas as PD. So we have the drive option correct. Data is equal to pd.read underscore CSV drive. Okay. Yeah, fine. Wait a second. I'll just try to read in another way. Let me see whether I can read or not. Okay, it's working like that, but there is some problem with the direct. Okay. So this may be happening because I'll just show you what was the problem in the data. Now I'm just showing you what I have just read. So this is the things what I have just read. So what was the problem? That in the data set, my data was separated by a tab. So you might have heard about the tab separated value and the comma separated value. So usually the CSV refers, usually not. So every time the CSV refers to the comma separated value, where the values like two columns are separated by a comma. But in the tab separated value, they are separated by space or one tab. So in my data set, the columns are separated by tab. Okay, and that is, but I am reading the function read underscore CSV, which is usually used for reading the CSV file. But right now I have the TSV file, and for that one I have to, along with the file location, I have to tell that my data is separated by a tab, and the header was not given. So I have given the header names. That first column name is label, and the second column name is message. Right. So this is why earlier it was giving the error, but once I have given all these parameters, then it has read my data set. Okay, cool. Now what I will do is I'll go quickly because that day we have already done these things. So I'll not spend much time that what we are doing here. Suppose feature extraction part we'll do first of all. That I'll show you that how to do the feature extraction part. Suppose I am extracting number of words in a sentence, right? So for that one, I am writing here the text. number of words in a sentence. So these are the sentences. Fine. And now I have to count for every sentence how many words are there. In every sentence, how many words are there in my whole data set. Earlier, we did it for one line. Now we have to do it for whole data set. Okay. So, excuse me 1 second. Okay. So what I will do is I'm just going to copy what I have written that day. Not going to write everything that that day I was writing. Otherwise, it will take more time. So what I've done is this is my message column, right? So in the message column, in my data frame data. So data is my data frame. Why? Because I'm reading it through the pandas, and whatever we read from the pandas, we say that it is a data frame. Okay, that is the terminology. So my data frame, I am selecting a column message. There are two columns till now. One is label, another one is message. So I'm selecting only message column, and this is how you can select a particular column. Then I'm applying. So there is a apply function, lambda expression. That day someone asked, sir, why there is a need of lambda. So I'll show you what was the need. That day there was only one sentence. Now we have the complete set of data where we have 5,572 rows are there. Okay. And in every data, in every sentence, I'm going to count how many words are there. Okay, so this line will do that one, and whatever output will come, that I'm going to store in a new column of my data frame, word count. Okay, so after this line, I'm going to print the data, and then let's see how the data looks. So see, a new column has been added with the name word count, and for every sentence, it has returned the number of words. Okay, and how it happened? Just because of this lambda expression. So what it does is it acts as an iterator. It fetch how it worked basically. First time it fetched the first data. I mean first sentence. It calculated how many words are there, and that it stored in this word count. Right, second time again it went on my second data, then it went on third data, fourth data, and like that it iterated in our data set completely. And for every data it calculated how many words are there in a message, and that's what it has returned at the last. So now I have 3 columns in my data frame data. Right, now we know that how it works. Those things I've explained you, so you can go through that recorded video. So if there is some confusion into that one, right? Okay, so next feature, suppose I am extracting that how many characters are there. Okay, the same thing what we did that day. So for that one I am creating new column with the name character count and applying str.len. So there is a direct function for counting the character, and this will do that one. str.len is a function that will count the character in complete data set. Now after this line, suppose I am printing the data. So what will happen? So it will have another column with the character count name, and it will have the number of characters in this message, or number of characters in second message or third message. So that things has been returned, right? So now whatever we are doing on the complete data set instead of doing in a single data. Okay, so what next? So we can calculate the number of stop words. That also we have done that day. So for that one, let me just paste the code from there. Yeah. So what we did that day, so we imported the NLTK. In NLTK, we downloaded the stop words, complete corpus. We downloaded first of all, and then in the stop words, we only selected the stop words of English, isn't it? And that we stored in the variable name stop. And this is the code why we wrote. You remember that first we are going to split all the tokens which is available in my message, and then we are going to match whether the go is available in the stop word vocabulary or not, until is available in the stop word vocabulary or not, point is there in stop word or not. So like that I'm going to check with every token in every message, right? And this code will do that one. And at last, when I'll print that one, you will have one more column with the name stop words. Let's see. So in the first sentence, there are 4 stop words. In the second sentence, there are 0 stop words. In the third sentence, there are 5 stop words. And like that, we have calculated the stop words in all 5,572 rows. So now, till now, we have extracted 3 different features: word count, character count, and stop words. Fine. Now we are going in the similar way. So I'm not doing anything new. Only thing is now I'm applying all the pre-processing or the feature extraction on a complete data set instead of one, what we did in the last class. Fine. So this is done. Now at last, suppose I have to extract the part of the speech features. Okay, that was the last feature we extracted that day. So let me just show you that one also. The code for that one is this. Remember, so we first created one dictionary, that for noun, what are the tags we are going to use, for pronoun, what are the tags we are going to use, and like that. And then we use the text blob library. Okay, and then we downloaded this particular PUNKT corpus, average perceptron tagger. So these are the things which I downloaded, which is necessary for counting the tag of noun, verb, adjective, adverb. Then we defined one function, check pause tag, which were accepting 2 different parameters. X represents the sentence. X represents this sentence in which we have to count the different parts of a speech available, the number of their frequency, right? And the flag says that what you have to count. I mean, you have to count whether noun or pronoun or verb of that. So 2 parameter it was accepting. We were providing that one, and then it was counting with this, that how many nouns or how many adverb or how many adjective is there in a particular sentence. Okay, we are calling this function from here through the lambda expression so that it will run for all rows in my data set. That's why through the lambda function, expression, we were calling this particular function, right? So this we did already. And suppose I will show you now, instead of this line, okay, I'll show you complete. So data, now see, it will take some time, because see, it has to run for 5,572 rows, and it has to extract noun, pronoun, verb, adjective, and adverb in every row. So now see, it is taking time. So meanwhile, it will take time. This you will see this action that it is running again, running and running. So once it will run, it will give you some number. For example, here it has given number 7, the previous cell here. Okay. But once it will run, it will have the number 8, but still it is running. We have to wait a while. So now see what it is doing. It is extracting tag. It is extracting tag for all noun, pronoun, verb, and adverb. Once it will be done, so after extracting the tag from all the data, from all the sentences which we have in our data, then it will count that a particular tag is present how many times in a particular sentence. So it is still doing that one. Let's see that how much time it takes. It won't take much time because it is a text data. So processing the text data is relatively easy as compared to the image. Image takes a lot of time. Okay, so yeah, I think it's done. It's done, right? Yeah, it's done. And now see, you have all the features for all sentences, 5,570 or 72 rows. Yes. Now see, we have word count, character count, stop word, number of noun, verb count, adjective count, adverb count, and pronoun count. So this particular line has done all the things. So I have to go along up. So everything it has extracted. See, I'm going up in my code. So that particular cell is completely filled up. So these things we have extracted. Okay. So now I guess this is sufficient, and these many features are sufficient. Now what I'll do, I'm going to build a classifier model, right? And I am going to give these features. Okay, I'm going to give these features to the classifier, And then we'll train that one first of all, then later on we'll test that one and we'll see what is the performance of that particular classifier, right? Okay, so feature extraction part is done. So what I'm doing is, first of all, that in this data set, data frame, I have many columns. For example, I have the column of label, I have the column of message, I have the column of word count, this. Now, you have to identify, or we have to identify, that which of these columns we are going to use as a feature, which column we are going to use as a label, I mean as a output, which one we'll use for input and which one we'll use for the output, which one we are not going to use at all. For example, see this message column, now we don't require. Why? Because from this message column we have already extracted these many features and we are going to work on these features, not on the message. Right? Why? Because I told you, remember the first day itself, that we cannot feed the data directly. Today also the Professor Adit Nigam, he was explaining to you that we cannot feed the raw text, right? We have to convert it into some form of numbers, right? There he converted every word into one hot vector, right? But now we are not doing that one. We will be doing it tomorrow, maybe, once we will be dealing with the neural network. But right now what we are doing is we are doing the feature extraction. So in the conventional algorithms, what we were doing, we were extracting the features manually. Okay, that was one of the, I mean, the time consuming task, or the you can say that was also mentioned by Dr. Jyoti Prakash Singh in the morning session, where he differentiated that what we do in the neural network, the feature extraction part we are trying to eliminate. That part is being done by the model itself. But earlier, like here, what we are doing for the conventional programming or machine learning models, we have to extract the features by ourselves. And that's what we have done here, right? Now, so suppose from word count till pronoun count, I'm using all these columns as my input to the network, to the model, this label as a output, right? So let me just write something like that. So I have created a variable named features, and in the features, what I've done is in my data frame. So this is my data frame completely, right? So in the data frame, these many columns are there, but I have selected only few. What are the things I have selected? I have selected word count, character count, stop word, noun count, verb count, and adjective count. That's all. I have not selected the message. I have not selected the label. So these two columns I left. Other than that, all other columns I have selected, and everything I have kept in a variable named as features. Right? Correct? So fine. Running the cell. Okay, so I have selected my features, means input is ready. Okay. Next, what I'm doing is that I'm converting this input. Sorry. I'm converting this input in the form of array. So there is a simple library, very simple line for this one. One library called as NumPy. Okay, NumPy in Python, you can use that one. So I have imported that one. The object of this one is NP. And through this NP, there is one function called as array. So this features, which I have selected, which is in the form of table right now, okay, or in the form of data frame, what I've done is I've converted in the form of array. So if after this line, if I'll show you how it looks like, it will look something like this. So not features, I have to show you feature array. So feature is this data frame, because this is the data frame, right, in the form of the table. But once I've converted it in the form of array, so it will look something like that. So the same thing, but the representation is changed. So it will have the 5,572 rows, same rows, with 1, 2, 3, 4, 5, 6 columns. So you can see that every list here. So we have list of list, array of list of list. So and every inner list has the 6 element, and every element refers to one of the features. Means first element like 20 refers to the word count. Here 111 refers to the character count. 4 refer to the stop word, 9 refer to the noun count, 1 refer to the verb count, and 3 here refers to the adjective count. And this complete line, it is a feature of the first message, right? This is the features of the first message. This is the feature of the second message. This is the feature of the third message, and this one is the feature of the last message, right? I think you got me. So this is what we have done. So we have converted our feature in the form of arrays, right? Now what next? So we have prepared our input. Now let's see how to prepare the output. Means, see here, the output is also in the form of text. Can we feed it directly? No, we cannot feed it. We have to convert it in some form of numbers, right? As I'm repeating this point again and again, because we cannot feed it as it is. We have to convert everything in some form of numbers, then only machine will accept that one. So for that one, suppose this is the things what I'm doing, right? So what I've done is class list. I've created one. See here, I've created one class list. I mean, one list I'm creating, that's all. Inside that one, I'm mentioning that what are the labels I have. So I have only two labels. See here, I have either ham or a spam, either ham or a spam, that's all. So I have created a list and I've kept two labels which I want to convert into some form of index, right? So I have kept it in a list. Then what I'm doing, see in the second line, that in the data label column. So now go back. So this is my data, I mean data frame, and this is the label column, right? This is the label column. Fine. So I'm going to do something into that column so that I can convert it. So in this particular column, I'm going to apply the same thing what we were doing till now. What I'm going to apply, that in the class list, so this is my class list. Inside the class list, what we have, ham and a spam. So I'm telling that apply class list dot index. Now what it will do, it will do a very simple job. It will give one index for a ham and one index for a spam. For example, suppose for ham, it is giving 0. So all over in my data set, wherever there is a ham, it will be now represented by 0. And for a spam, suppose it is giving one index 1. So all over in my data set, wherever there is a spam, all will be represented by 1. So that is the simple job which will be done by this class list dot index. And where we are applying this one? In my complete data label column. Getting this point? And then the next line is very simple, that whatever index I will get, I'm converting that in the form of array. The same thing what we did here, as array, np dot as array, and then np dot as array. Same thing. Let me show you how it will look like, that how label will look like. It will look something like that. That all my ham, so you remember the first two data was ham, the third data was a spam. So you see here also, first two data is 0, 0. Why? Because for ham, it has given the index number 0, and for a spam, it has given the index number 1. So, and then there is a dot, I mean all the data which is in between. Okay, so now what we have done, we have converted this in the form of index. Okay, now we can use it. Earlier, we were not able to use it because it was in the form of text, ham or spam. It was written in the text, but now it is in the form of index, means in the form of numbers. Now we can use it. So what we have done, we have prepared our input and we have prepared our output. Now let's build the model. Let's build the model. But again, before building the model, one more thing I'll explain you. That in my data set, we have not differentiated that which data, how much data will be used for the training and how much data will be used for the testing. But as you remember that I mentioned in the second session when I was taking the session on introduction to machine learning, I told you the machine learning system always works in the two phases, training and testing, right? So I have the combined data set now. So let me just divide this data into two parts. Okay, one part will keep for the training and another part will keep for the testing. How to do that one? So this is how we will do that. So I'm going to use sklearn library. From sklearn, there is something called model selection. And inside this model selection, there is a function called train test split. Means I'm going to divide my data into train and test. Isn't it? That's what we want to do. So I'm going to use this function. And then I'm applying this function here, train, test, split, and see what we are passing inside this function. Let's see. There are 3 parameters which I have passed. First one is feature array. What is feature array? This is my feature array. I mean my input. Whatever input I have prepared, that is my feature array that I'm passing here. I am also passing the label, which I have just converted into in the form of indexes. Yes, any question? No. Okay, fine. So I have passed the feature, I mean the input. I have passed the label, this is the output, and test size I am giving 0.3. What does it mean? I am telling this function to divide this feature and array such that it will be divided into 2 parts, and the test part will have only 30% of the data. I mean, if I have 100 data total, so 70 data I will keep for the training and 30 data I will keep for the testing. That's the meaning of this parameter, test size 0.3. You can change it. You can keep 0.2, 0.1, and accordingly, that percentage of data will be kept for testing, or it will be in the testing set, right? And see what it will give the result. What it will give the results, because this feature array is going to convert into 2 parts, one for training, another for testing. So this feature array will be divided into X train and X test. So X train means the input of training, right? And the X test will be the input in testing. Similarly, this label will be divided into 2 parts, Y train and Y test. And Y10 we will use the label in the training case, and Y test will use while doing the comparison. I mean, in the testing we are not going to use the label, but after the prediction we are going to I'm going to show you that how to find the classification report. For showing the classification report, you should have the actual label and the predicted label, and then you are going to see how much error and all you are getting. So okay, with these 2 lines, what I have done is I have divided my data into the training set and testing set. Let me show you what will be the training set. So the training set will be how many data will come in the training set and how many data will come in the testing set. So this X train and Y train in my training set, where X train is my input and Y train is my label. X test and Y test is my testing set, where X test will be the input and Y test will be the actual output. Right? And let me show you the shape of this one. So total 5,572 data we had. Out of that, 3,900 we will give for training of the data, and 1,672 data have been kept for the testing. So you can see I have kept here 0.3. That's why 30% of data have been kept for the testing. Well, now we have divided our data also into the training and testing set. Now we are ready for building the classification model. And building the classification model is the easiest thing what we are going to do now. So till now, whatever thing we have done, that was the complex thing. But classification model building is the easiest thing. Why? Because we are not going to do anything from the scratch. Okay, so what we are going to do, we are going to use the library, and that is why it is very simple. For example, let me just show you now that suppose I am going to use the SVM, support vector machine. That is the classifier. So where is that classifier, exactly the code or definition of that SVM? That is one of the library called sklearn, ARN, right? So in the sklearn dot SVM, so see if I put S, V and M, so it has come. So from the sklearn dot SVM, I am importing something called as SVC, support vector classifier. That is the meaning of this one. SVM means support vector machine. So support vector machine can be used for both. Support vector means for the classification and for the regression. I am using it for the classification right now. Why? Because my data set is a classification data set where I have to classify every message in either ham or a spam. So this one I'll first import. That is the one line. Second line is I'm going to call this one. Whatever I have imported SVC, I'm going to call that. And once I'll call, I'm going to make a I'm going to make a, suppose, object for this one, right? And suppose this is the object as model underscore svm. Fine. So this is the second line. What I have done is I have simply called this function, and this function is for the support vector classifier. Third line will be that this model which I have, which is the object of svc, on this model I am going to fit. Fit means what? Fit means training. So this model I am going to train. How we train the model? By providing the training data set. And what is the training data set we have? This x train and y train. So let's pass this x train here, excuse me, and this y train. So with the input and the label, this model will get trained by itself. Okay, and then that's all. One line I will write and the training will be done. Okay, after the training, what we have to do? We have to do the prediction on test data. Okay, and for that one, again we'll use this object of svc model underscore svm, which we have created, and then we'll write dot, and there is one function for prediction is called predict. This is the function, and inside this function what will pass? The testing input. So testing input is x underscore test. That is my testing features are in x underscore test, and that's what I'm passing here. All right, that's all. The 4 line, and my training and testing of the svm will be done. And after that, if I want to print something, I can print like svm, and then I can print these should be small. And again, if I want to print, suppose, wait, I'll do that in the next line. I'll just show you. For this one, let me cut this here and let's paste it at the top. All right, so see, that's all. So what it has done, so first, in the first line it has printed the svm, so you can see also here the output. Then it has imported this svc, it has called the svc, created one object model underscore svm, then trained the model svc by calling the fit function and providing this training data set, and then predicted what is the output of the testing data set. So that prediction you can see in this form of the array. That means in the prediction data, the first message is classified as 0, and you know that 0 we had given for the ham. Second data also classified as 0. Third data also classified as 0. Then there are many other data in between, and the last 3 data also classified as 0. Okay, I'm not talking right now about the accuracy and all, but this is how it has done the classification. Fine, prediction. Now, once you have done the prediction, what is the next job? The next job is to check that what is the model performance, isn't it? We have to check that what is the accuracy of the model, for example, isn't it? Accuracy. And for checking that one, again, I'm using one of the library, because otherwise you have to write the code from the scratch. You have to write the formula of the accuracy in the form of code, and that if you don't want to do, you can simply use this accuracy score. That is a matrix which is available in the sklearn library, and you can call this function. So if you'll call this function, and if I'll print suppose accuracy score is equal to, and then what I'm going to do is I'm going to call this function accuracy score. And how do we check the accuracy score? By providing my actual input, my actual label and the predicted label. So for the testing data, X test, what is the actual label? Actual label is Y test. Actual label we have in our data, which is given as Y test. What is the predicted label? Predicted label we have not stored. So wait one thing, I will do one more thing, that Y underscore predict underscore svm, I write. So this is the variable I have kept just to store all the prediction of this model. I'll run this cell again, and then this prediction I will pass here. So I am passing the actual label and I'm passing the predicted label of SVM. And then I'm trying to see what is the accuracy score. I'll run the cell and it will give me the accuracy. Now see, the accuracy is 91%, 0.91. It's not bad, right? It is, we don't know how it comes because we have not done anything, any tuning in my, tuning of parameter in my model. But see, we have not done any tuning, but still the model is able to classify my data with a 91%, and that's not bad. 91% of the data has been classified correctly. That is the meaning of this one. Similarly, you can also import many other classifiers. Okay, you have, so what you will do whenever you will use any classifier, first you have to import that one. First you have to import that one, then call that one, then fit that one, and then predict that one. So 4 lines, only 4 lines of code, you can build the classifier. For example, for logistic regression, if I want to build, I'll show you one more. Okay, for logistic regression, what I'll do is from sklearn dot something called as linear model, and inside the linear model there is a function which is defined for logistic regression. Okay, logistic regression. So what I've done, I have imported that one. Then what I'll do is the second line, what I told you, you just call that function. Whatever I have imported, call that one. So let me just call with the object name LR. Okay. Third line, I told you, you have to call the fit function. And inside the fit function, will pass the same data set because data set is same. So for training, I'll pass X train and Y train. And finally, for prediction, let me write Y underscore predict underscore LR. Okay, underscore LR in capital is equal to LR dot predict. So predict is a function name. And what will pass here? The testing data. So okay, that's all. And then this is done, and later on you can print what is the accuracy you are getting. So accuracy score for this is for LR. So let me write that also for logistic regression. See what is the accuracy we are getting. So it is almost the same accuracy. In fact, it's same because the data is same. We don't know why it is, but see, the point which I want to make here is that don't worry about the accuracy, why it is same and all. That is a different thing what you have to tune and you have to check and all. What I want to convey the message here, that if you want to build any classifier, only 4 lines you have to write. In the first line, you just import that classifier from a library. In the second line, call that particular classifier, then train that one and test that one. So with this 4 line, you can build any classification model. That's all. Why? Because we have a rich library. Otherwise, we would have to write the code from the scratch, which is not possible. I mean, at the first hand, for that one, you should have the proper, the coding skills and all. Okay, and like that, you can use many classifier, you can build many classifier, and you can check which classifier is working better, and that you can use for your data set as a final classification model. Right, so I'm going to stop here for 5 minutes so that you can ask me any question related to this. Otherwise, then we'll start with the image. Okay, so please ask me the questions if you have not understood anything regarding classification model building.
Hello, sir. Good afternoon, sir.
Good afternoon, ma'am.
Sir, first, in the first step, you are importing the data, right? So that means we want to first upload the that means Excel sheet or .csv file you are uploading in your drive only, no, sir?
Correct. Yes, ma'am.
From that drive, you are accessing the data.
Yes, ma'am. Yes.
For that, you are writing that path.
Yes.
That's it, sir. Okay.
That's all.
Okay, sir. Thank you.
Okay. Any other question? I mean, it was understood or it was not understood. I mean, whether whatever I have told, because most of the thing, it was the repetition for us, isn't it?
Yeah, it's very good, sir.
Okay.
I understood quickly.
Thank you, ma'am. Okay, so let me see the comments, sir. If we want to build the model with some selected feature instead of all feature, what to do? Okay, very simple. As you can see in my screen also, where I've selected the features, I'll just tell you. So here, suppose I want to build my model only on this one. Suppose noun count, verb count, and adjective. So I will select only these features from my data frame or from anywhere, wherever you have these features, okay? And that's all. Now what will happen that in my data, in my features, only 3 values are there about the noun and verb and adjective. And with that only, I'm going to train and test. So it's very simple. Selecting the feature. So extracting the feature is a bit difficult, but selection only on few features or not, that could be done by this. Or else, if you are asking in some other aspect that which features are really prominent for the model, which features do not have any contribution towards the model performance, for that one we have some other models. I mean, the machine learning like analysis you have to do. Okay, you have to check. Maybe suppose we have started with all these features in starting, and then when I plotted what I saw, you have to check that what is the correlation. I mean, you have to check the correlation that in predicting the class value, what is the contribution of this word count, right? Or in predicting the class, what is the contribution of this character count or the stop word? And suppose you come across that this stop word is not doing anything, so you can remove this one. Okay, so in the starting, you can start with all the features which you have extracted. Then you can find the correlation between the output and all your features. So there are some other libraries which is available for that one. Okay, so you can find it out, and then you can check which features are giving some contributors, I mean, maybe 60% contributing towards prediction of the label of the test data, and which features are not contributing at all. So now you can remove, you can select by yourself that which features I should keep for training or which features I should not keep. That's how you have to select the features. So you have you have to find the correlation. So there are many correlations things, like for example, the some correlation coefficients are available. Okay, you have to find it out. That some, I'll give you some of the, I mean, the library where like for example Pearson correlation coefficient. Okay, based on the Pearson correlation. So correlation means what? Between the input and the output, how every features are contributing. So that correlation you can establish, suppose using the Pearson correlation coefficient. Find it out, the library for the Pearson correlation coefficient in the web, I mean in the Python sklearn library, there is one function for that one. You can use that function directly, pass your all the features, okay, and the prediction, and then it will return you that which features is contributing how much towards the prediction of the label, and then you can select it. So Pearson correlation coefficient, you just try with that. There are other correlation coefficients also. Oh, I would expect to naturally observe a higher training accuracy than test accuracy. So 90% is test accuracy. What about training? Yeah, training accuracy usually I have not. Okay, let me just see whether I can show you or not. So training accuracy, obviously it should be higher. Okay, in the ideal scenario, it should be almost 1. Okay, it should be almost 1, that you have learned everything from the data. And then testing accuracy could be, I mean, it may not be completely what we have as the training accuracy, but it can be nearer to that one. Suppose you are getting the training accuracy as 99% and testing accuracy as 95, 96, 97, then your learning is good. But suppose you are getting the training accuracy as 99% and your testing accuracy just 70, then your learning is not good. I mean, fine, for training data your model is giving good accuracy, but for testing it is not behaving good. Okay, so sometimes it is also called as the overfitting. Okay, that for training it's giving very good result. For testing data, it is not giving a good result at all. So that is called as the overfitting. Okay, so testing accuracy I have not shown you here, but again you can find it. What is the testing accuracy? By passing your testing, you have to store all of whatever you have after the training, whatever the parameters or whatever the prediction this model has done, you have to store in a particular, I mean the variable, and then again you can use this accuracy score, pass it with the actual training level, and then you will get the training accuracy. Okay, that will show you later. Right now I will go with the other thing, but tomorrow when we'll do the neural network, that time I'll show you how to see both, or else our colleague or other Professor Roy, he will show you how to see the training accuracy and as well as the validation or the testing accuracy at the same time, and then to judge whether my testing is good or not. So that will show you. Okay. Okay, so print y underscore predict LR in logistic. What is that? This one you want to print. Okay, so let me just print this one. So this will give you all the predictions. This will give you all the predictions. Don't bother about the numbers what we are getting here, because I have not put any effort. Okay, for getting the 100% or 90% accuracy. I have simply downloaded, simply I'm calling the model, I'm building the model, training it, testing it. I'm not doing any other extra effort. But in reality, I'll just tell you that this SVM have lot of parameters inside. I mean, lot of parameters. You first, for example, let me just write this one, SVM. I don't know whether it will come or not. It's not coming right now, but yeah, SVM. Anyway, so yeah, this one. As soon as you will click on the, sometime what happens, as soon you will click on a particular function what you are using in your case, then what will happen? See, this SVM has a lot of parameters inside. For example, it has the kernel, it has the degree, it has the gamma coefficient, and once you are really doing the research, you have to keep everything in mind, that which parameter value what you have set. I have not done anything. I have not put any effort in building this particular model. Okay, so that is a long process. Basically, while doing the research, getting the result, that is a long process. Okay, so you can dive into that one, see what are the parameters is that, what is their working, how we can change, what we can keep, try with all the possible combination, and then you can think about the accuracy, that yes, if we are getting 91%, that why we are getting, can we increase still somehow or not. Okay, so right now please do not bother about the accuracy. Yes.
Excuse me, sir.
Yeah.
Sir, in finding the accuracy of LR model, you have passed SBM model.
No. For LR model, SVM, these two are independent one. You can do first this one, then this one.
No, you have passed Y predict thought SBM.
Okay. So
That's why it's same.
okay. Thank you so much. That's what I was surprising. Why it is exactly same? It should not be exactly same. Now you can see. Yeah. Thank you so much. Thank you so much, sir. Yeah. Okay, so don't bother about the accuracy, okay, and these mistakes, yeah, we do commit and later we realize. Thank you so much, yeah, for identifying the mistake. Hopefully this is clear, that how we build the model. So all the machine learning model, I'm telling you, you can write it in a 4 lines, you can build your model. The only thing is, the next part is very difficult, that you have to go each and every parameter of that model, okay, tune those one. Okay, and then accordingly you have to check what accuracy you are getting, whether it is sufficient or not, and all everything. Okay, so that is different story, but building a model is very simple. We're using this sklearn library. Any other question? Error in print statements. Okay, fine. Don't. What is the error? Let me just know. Otherwise, why the compiler is not giving? Okay, fine. Any other question? Then fine. Otherwise, I'll show you quickly, because we are just left with 15 minutes and I have other classes at 4. So I'll show you quickly now the demo of image. I have prepared already because I was knowing that we will be running out of time. So I prepared one notebook. I'll be showing you that one. Okay, let me share that slide. I mean that notebook. Yeah. Okay. Image demo. Dap. Fine. So I guess you can see this file image with the name image demo. So how to read the image if you have that image in your drive already. So I showed you how to keep your file in a particular folder in the drive, and then how to navigate to the drive. So you can navigate it. So now it is connecting, it will be connected. And after the connecting, we have to do the mounting, and then we can access all the, so mounting is being done as you can see here, right? And once it will be mounted, I will have the access of my drive, right? And then I'm navigating to a particular folder. For example, I'm navigating to my drive summer internship, for example, this one, and inside that one, my test file, where it is, yeah, here, my test file, then inside that one Sunil, then inside that one multi-offensive data set, multi-offensive, where it is, here, multi-offensive data set. Inside this one, again we have one folder called labeled images, right? So I am checking with this, and now see there are many images inside this. It's opening, it will take a, so these are nothing but an images, these are nothing but an images. So there are many images, right? You can see that there are many images. Okay, fine, I had showed you where it is exactly. Now what I'm doing is I'll first read the image, a single image from the file, and then I'll show you how to read all image which is available in a particular folder. Okay, now for that one I'm using the CV2. It is again a library for image. There are many library available. I'm using the CV2 right now. Okay, another thing which I'm importing here is OS, operating system. Why I'm doing that one, I'll tell you later on. So reading single image. Okay, so these two lines are clear. So in this line, so inside the CV2 there is a function called IAMRead, because we are going to read image. So IAMRead means image and then read. So that's how they have kept the function name. I'm giving the path of that particular image which I want to read, and that's what I have given. So till here is the folder path, and this is my image name 00DJNZR.png. Okay, and I'm going to run this one. So this will run this particular image. So in this image, what we have got is this matrix. So you remember in the morning session also, when Dr. Singh was explaining the deep introduction to neural network, he was explaining about a bike. So we see bike as a bike, but the computer see the bike as a matrix, isn't it? As a matrix. And then moreover, if it is a colored image, it will have the three channel. It is a three channel matrix. One channel is for red, another channel is for green, and third channel is for blue. So red, green, blue. Okay, and that is why once I have printed this one, you see that I have three-dimensional list. Why three-dimensional? Because there are three channels. Suppose there is a black and white image, or also we say that it is a grayscale image, then you will have only one channel. But because this image, which I have read just now, is a colored image, so once I will print what I have read, it will show me the three-dimensional matrix, right? And that's why this one. So see, one image is being represented by these many pixels. So everything, all the values what you are seeing is nothing but pixels. Okay, okay, what is that image? Let me just see that also. So first one, I'm reading this one, image visualization. So so till now we have seen the image in the form of matrix. Now let's see the image itself, visualization. Okay, and then the same image, to visualize that one, I'm using the matplotlib. I'll show you the visualization of image using CV2 also. But before that, I'm using one library called matplotlib. Inside that one, I have the pyplot. Okay, and that for that one, I'm using one object PLT. So through this PLT, I'm using one function ImShow. It means image show, and then passing my image file, which I have just read. So image file is my is the variable name in which we have read the image, and that I am passing here inside this one. And once I run this cell, it will show you that particular image. See, now you are ready to vote for Hillary. So it is a meme basically. So we are going to make fun of someone. Okay. So anyway, so this is an image. So you can read any image, something like this. Now, if I will try to use the same function or try to show the image using the CV2, what is the function? So same thing. So see, inside the CV2, you have ImShow. This is the function name. Image show is the function name, which is also available inside the library CV2. Okay. And through this function, if you will pass two parameters, the second parameter is your image file. See here, image file here also we passed. Image file here also I'm passing. Okay. What is the first parameter? First parameter is about the window, right? So you need some space. Why means, see, this image, it is showing, still it is showing. Why? Because it has been allocated some space in memory, isn't it? And it is holding that space, and that's why it is still visible to us. Are you getting the point? So we need to create one window where we want to show the image. It is not just like the text. Usually the images are very complex. See this three-dimensional matrix, how complex it is to read and understand. And the size also, if you will see, one image size is in MB, 4 MB, 5 MB. But for the text, once you are showing the text, for example, one sentence we have to show, it is in KB and even in bytes, some bytes, right? Not in kilobytes also. And that is why we need to create some window. And in that window only this image will be shown. So the first parameter is about the creating window, and in that window, which image we want to show, this image, right? Second function, wait key, it says that how much you have to wait. I mean, once this image will be visible, for how much time you want to hold that image in that window. For example, suppose I'll keep here 1. So it will hold that image in my window just for suppose 1 millisecond. But if I'll keep 0, it will hold that image for infinite. I mean, it will hold that space completely, right? And this function destroy all windows, it is there because for suppose like this, we have created many windows, and in every windows we are showing one image, and we are showing the image for infinite times, then it will consume all my resources, isn't it? And that's why once we have shown the image for some time, suppose I'm going to destroy all the windows which I have created. That is the meaning of these 3 lines. But surprisingly, once I run this line, it gives the error. It gives that this function is disabled in the collab. It's, as you can read that one, disabled function error. What does it mean? Because see, I have told you just now that for every image, if you want to show in the window here, you need some space, or you have to create some window, right? And if you are keeping wait key is equal to 0, it means that image will be visible for infinite times, unless you are not pressing any button and you are not coming, or you are not shutting your system. Okay, that is the meaning of this line. So it may happen. So I'm showing you just one image, but if we have suppose 1,000 of images, or suppose we have 50,000 of images in my folder, and all together I'm reading all the images at the same time and showing all the images in my window. So see how much space it will consume. And what happened at the last, you will not able to do, your system will get stuck. Okay, you will not able to do any other operation in the system. And that is why, because the Colab has the limited space. Again, it does not have the infinite space. It has to give the space to all its user. Okay, and that is why they have disabled this function. So this function will not work in Colab. Excuse me. But this function will do work in your local system if you are using the Anaconda and all. So what is the alternative? The Colab has given its own function that from google.colab.patches you can import cv2.imshow, and then cv2.imshow can show you the image. So Colab has the handling mechanism, right? Okay, now read multiple images. So this is how you can read the image, you can show the image. How to read multiple images? So for that one, you can do something like that. This one I'll skip. This one, yes. Okay, so you can do something like that. I'm defining, suppose, one function, load image. So first of all, I have to load all the images, isn't it? See, there is one folder in my drive in which all the images are there. Here, I loaded one image. Here, I loaded one image, and then I printed that one, or I visualized that one. But to read all the images from that folder, first I have to load that one. And for that one, how to load? There is one parameter in my function is path. So if I know what is my path, the complete path till the labeled images I have given, right? Inside this function, if I will give this path, what I want that this function should return me all the images in that particular folder. But how is that possible? Because I have the path, but I am not giving any particular image name. So somehow I have to merge the path with all the images name one by one. And for that one, we are using this OS. So I am giving the instruction to the operating system that in this particular path, do some join function. Okay, apply some join function and merge the path and the file name. Now, what is file name? For that one, we have kept a loop, right? Because we have many files, right? We have suppose 1,000 images, and every image file name is different. So how we are fetching the file name? So we have kept a loop. So file name in os.list directory. Now see this, what it will do. This is a function list directory. We are passing path inside that one. So inside this path, whatever files it will have, whether it will have the file or folder, everything it will list everything, right? And then what I'm doing, because I have kept here for loop, I can fetch all the file one by one. And every time whenever I'm fetching a file, I am joining that with this path. Are you getting? Okay, and then this is how I'm loading all my images. And that's so load image, this is a function name I'm calling from here, and whatever that combined path plus image file, what I'm getting, I'm keeping in this loaded image file. So if I'll show you what is there in this loaded image file, I'll show you. So there are 749 images. I'll see that. So what I've done is in this path, see at the last till the loaded image, everything is same, but after that the file name is different. So what I've done, I have combined all the files with the same path, and that I have kept here, okay, in the loaded images file. So this is how you can load all the images from a folder into your Python code. And suppose once we have done, there are 749. This is the problem. That's why I don't want to. Okay, let me just comment again. Right. Then what you can do is you can read all the images. Suppose I'm not reading all the images because it will take a lot of times. So what I'm doing is in my loaded images file, which have 749 images, as you can see here also, I have printed the length of that one. I'm only selecting 10. 1 to 10. Instead, I will select only 5. Okay, I'll select only 5. Again, I'm keeping the for loop. In this particular list, one by one, I will fetch each image and I will read that one using the cv2.read function. cv2.imread function. And see, for 5 images also, it has taken a couple of seconds, right? And that's all. So this is how you can read all the images at once, okay, inside your folder. Then you can do many pre-processing tasks for the image, like a split channel, merge channel, resizing image, smoothing image, and edge detection. Okay, it's time. I'm going to stop right now because I have class again at 4 o'clock. I can take a couple of questions now. If I will have time, suppose tomorrow or day after tomorrow also, I'll explain you the different pre-processing things which we can do with the image. Otherwise, I'll share this notebook with you. Yeah.
Please share the recording of this one.
Yes, sir. Definitely, I will share.
Because we have to, I mean, we on one go, we cannot understand all these things. So we have to repeatedly see this one and learn.
Yes, sir. I'm sharing all these things day by day, and I'll definitely share.
Okay, thank you.
Okay. I hope whatever I have told, that much you understood how to read multiple things together, but we are running out of time, so I have stopped here. If we'll get the time, again, I'll explain you, definitely. Any question if you want to ask? Okay, so if we do not have any question, shall we wrap up? Just in image x-axis values are increasing in order, while in y-axis reverse y. Let me see what you want to say. So in the matrix, I guess you are talking. What is the x value or y value? I did not understand clearly. So these are all the pixels value between 0 to 255. Okay, if okay, we'll I don't know what you asked Vishal sir, but anyway, so if we see that we can resolve this in the next session, will it be
Hello.
fine? Yes, sir.
Sir, actually, the values of x-axis in image that you have shown, the values are mentioned like 0, 50, 100, 200, 400. The values actually, are
Let
cells
me
value.
share the screen, sir, so that I will understand
Okay.
where exactly is. Sure. Yeah, this one. So you're talking about this matrix, right? This matrix.
No, no, sir.
No,
After this matrix image, yes, yeah, yeah, upper one,
this one.
upper one, sir.
This one.
Yeah, yeah, yeah. On x-axis, these values are 0, 100, 200, 300, 400. But on
Okay.
y-axis, these are in reverse order.
Okay. Okay. We have see their function has plotted it, but these I mean the meaning of that one is that here in this side the pixel values are in between 0 to 700. This simply represent the 0 to 700, and it will be 0 to 400. So they have plotted it in some way, but we can again modify it. It is not correct one. Okay, it is not
Okay,
correct.
okay, okay, okay.
Yeah, you can plot
Okay,
it in a correct way. Yes.
okay. Thank you, sir.
Okay. Okay. Fine. So simply they have given some range, but see this here when we plot it, then there is no range at all. So they have simply given the range. Okay, because the matplotlib usually give the range and then plot the things. Okay. Right. How to accept feature from any classifications? Okay, madam, I will show that one. I'm telling that in the next session, if I'll time permit, I will definitely explain you that also. Some of the feature extraction, what we can do from the image. Multi-model we are not showing you right now because we don't have that much I mean time, right? Because see, tomorrow I have scheduled it for the text classification, so how to read the text and how to prepare the text from the neural networks, then how to build the model, how to train the neural model, and how to do the classification. So it will take again 1.5 hours. Right. So multimodal, the sense image and text, if we have both, then how to feed that? It will take some time. Right. So you can like contact me through my mail, and then we can have some other time conversation, I guess. That would be fine. Okay, then all of you, thank you so much for attending the session. Right. Hopefully the sensor sessions are informative. Okay, you are getting the benefit from that one. I'll be sharing you the recorded session. Okay, again by today night, maybe this notebook, whatever I have explained you today, that also I'll share. Right, and please connect tomorrow in the fourth day. Very informative session of CNN, convolutional neural network for the text classification. Okay, and that is the one thing. The second session, then we'll see the optimization, right? Because sir, you like the Aditya Nigam sir, he was mentioning about the parameters is very huge in when we talk the neural networks. Okay, and sometimes it is very important to optimize those parameters. Okay, so the second session of tomorrow will be on the optimization. Okay, in neural network, where we'll learn something, some optimization technique, right? And in the third session, again, we'll have the hands-on CNN for text classification, and that will be handled by the Dr. Roy from the IIIT Surat. Fine. So please connect tomorrow again at the same time. So 9:55, 9:50, and we'll start the session sharply at 10. Thank you so much. So I'm wrapping up now.